for joining in. So, actually, I have been thinking about sharing this video for quite some time. It is a use case that we have at work, and I thought it will be really useful to the community to show a workflow which helps to scale and manage large shiny apps. Right, so this is specifically for apps which actually grow bigger with time, and how we have used some of the techniques that I'm going to share in this video, which has really helped us to manage a very large Shiny app. So, to give you some context on the background, let's start with a DQL, which is a data quality lead. A DQL is a person which is responsible to manage studies at different sites which are happening. So he or she is responsible for managing studies and then tracking its progress, how things are progressing, and how if there are any blockers, what they need to do to solve those blockers, etc. So the role of the DQL is actually multifaceted. They need to do a lot of different things. In our context at work, actually, the DQL, to perform their duties, they need to switch between different tools, right? So, for example, they want to get some metrics on the study that they are responsible for. They go to tool one, download some statistics, and then they open it in Excel and do some transformation, summarization, etc. And then through email, they send it out to the stakeholders. Right. Now, for the DQLs who are technically savvy, they have their own formulas which they have built in Excel, right? Macros as well, which helps them to do this regularly. So, one of the challenge is that the formula that they're using is not standardized. So, based on their understanding of what a particular metric means, they have devised their own formula. Um, and they have come up with their own macros and own algorithms about this, and they share these statistics with the stakeholders, right? So it's not standardized for every DQL. Moreover, they have some other responsibilities as well, where they need to send out reports on weekly or monthly basis. Depending on the report, the frequency changes. Some reports they need to send it out on weekly basis. Some reports they need to send it out on monthly basis. Right, so these were few of the challenges that a DQL faced, right? And we were trying to solve it by building a single tool which a DQL can use, and everything that they need is available in this single tool. Right, so right now they were switching between tools. If they want to do task one, they need to go to tool one. If they need to do task two, they need to go to tool two. And if they need to do task three, probably they need to go to multiple tools, etc., and do some manual transformation themselves as well. Also, by building this standardized one way of working, then we can also formulate and standardize the formulas that are being used. So if study one team is using a particular formula for a particular metric, study two team would also use the same formula, because the both study teams are using the same tool that we'll be providing. So that is the goal, where we want to have one common tool, a one common platform where a DQL can come and do all the work that is required for them. Now, as you can imagine, right, there are multiple tools that they are currently using. Now, bringing them into a single place is going to be a big challenge, and we are starting from scratch, right? We do not have anything in place and we are starting from zero. So, let me show you how we came up with the first POC, the first prototype. I built a rough sketch, and it's not technical at all, it's not pretty at all, but just wanted to convey the concept, like what it is and how it works. So, let me share my screen. And this is the first draft which I wanted to share. Now, the one on the left hand side, this is the Shiny app, right? We used R and Shiny as the language or tool of our choice, because that's what we most commonly use, right? So it's a Shiny app. We came up with the solution that we build a Shiny app where this Shiny app would be a single place a single source of truth for all the DQLs, right? So on the left, you see a Shiny app, and here on the sidebar, you see app 1, app 2, app 3, right? And this square that you see is like when you click on app 1, you see the contents of app 1. Here, when you click on app 2, you see the contents of app 2 here. And similarly for app 3. Right, so let's assume that each tool that a DQL used is converted into an R Shiny app here in app 1 and app 2 and app 3, correct? So this is how it works. On the right here, you see it's like a Git repo, a single repository that we use to store the code. Every every repository we package it as an R package because it has a lot of advantages. So it is a single R repository wherein you have an app.r file, and then under R folder you will have different functions. You have a UI and server function, and then there are different modules. We divide uh, different functionalities into modules, and then we call them an UI or server function, right? So it is a standard package structure that it follows, but it is a single repository. So although we have apps as app 1, app 2, app 3, everything sits in a single repository, right? All the code base sits here. So we shared this POC and it actually worked really well. And all the stakeholders liked the idea, and we were told to go ahead with this and build a full-fledged app. So as you can imagine, this is going to grow. It was a quick, dirty way of building a POC, but it's not scalable. So as you can imagine, in the future, this app 1, app 2, app 3 would grow to, till 6, 7, or even 10 apps in the future. And if we keep everything in the single repository, the code base is going to grow huge, and it's going to be very difficult to manage it, right? Where all the code sits in one single repository. So we needed something better. So what we came up with was a multi-repo structure. So let's assume that each app gets divided into a separate repository. So the code gets separated. And this is how it looks. There is a main repository. On the left-hand side, the Shiny app has not changed. It's still the same, right? The right, the Git repository has changed now. So we have a main repository where the entire Shiny thing sits, right? But for each app, now we have a separate repository. So there is a separate repository for app 1, there is a separate repository for app 2, and similarly for app 3. All of these three repository again follows the same R package structure, wherein you have app.r, you have an R folder, you have tests, etc. We did one thing, which is to export the UI and server function from each app. So in app 1, we have exported app 1 UI and app 1 server, which we call here in the main repository. Now in app 2, we have done similarly, wherein we have exported app 2 UI and app 2 server, and similarly for app 3. Now, although this repository sits differently, the code base we have separated, but they are still being called in the main repository. And now we deploy this main repository only on the server, and this is what the Shiny app looks like. Works the same way. It really works well. As we move from the POC stage to the actual production stage, the teams also grew. So there are like different developers working on app 1, there are different developers working on app 2, and similarly for app 3. So it was really important that we have the separate places where people are working, a separate code base where people are working, and they're able to manage things in their own repository. So now, although we have done this, there is still one major challenge. If you notice, everything is being called from the main repository, right? So we are deploying this main repository. Now let's assume that there is a bug in app 2, okay, which is not handled correctly with try catch or some other mechanism, right? So there is a bug which is happening in app 2, and if the app crashes, the entire app crashes, right? So even if there is a bug only in app 2, it breaks the entire app because everything is being called here. So now we had to think that was not a suitable solution or a suitable scenario where we wanted to be in. So we started thinking of ways how we can avoid that and how we can actually avoid the single point of failure. So this main repository was still a single point of failure, right? So if anything happens here, it breaks the entire app. So how can we separate out uh, these apps so that it does not impact one another? We brainstormed a lot of ideas, and finally we came across an idea called as iframing. So this is not a iframe is not an idea specific to R and Shiny apps. It's a web development idea. It's basically an HTML element which allows you to embed any content on a website, right? So on a web page. So you can embed a web page within a web page. You can embed a video in a web page. You can embed text in a web page. It could be anything. So iframing is just, you can assume that it's a simple window wherein you can embed anything that you want. So what we did is we already separate out our code bases in app1 repo, app2 repo, and app3 repo. Now we deploy them as it is. App1 gets deployed on URL1, app2 gets deployed on URL2, app3 gets deployed on URL3. And now in the main repository, what we do is we just have a link, an iframe URL, that when you click on app1, show app1 iframed URL. When you click on app2, show app2 iframed URL. And what this has helped us is really helped us achieve scalability and maintainability of such a large Shiny app. So now, if there is a bug in app 2, only app 2 gets crashed and the entire app, the rest of the app works as it is, right? So only app 2 has an issue that needs to be fixed. Rest of app 1, app 3, and the main repository works very fine. So it's just a link which we have provided, and everything happens on the server side of app 2. So this really helped us to separate out uh, deployment processes across apps and also avoid the single point of failure that we had. Moreover, in the future, actually, what we also did was we had two versions of each app. So we have like a production version and then we have a develop version. So there is like app1 prod, app1 dev, there is app2 prod, app2 dev, app3 prod, app3 dev, and similarly main repo prod, main repo dev. So main repo dev points to app1 dev, app2 dev, and app3 dev. So what happens is when you merge your changes from feature branch to develop branch, the dev instance gets updated, and in the main app, the develop deployment, you can see all your changes and verify before it moves to production. That really helped us to also catch a lot of bugs and errors before they reach production. So that was really helpful. Apart from that, in the future, what we did, like the number of apps on the left hand side actually kept on growing. So, and again, it was not scalable to have, app 13, app 14, app 15, etc. So in the future, we also came up with clusters. So we have clusters of app based on the different categories. So cluster one would have app 1, app 2, app 3. Cluster 2 would have app 1 and app 2, and so on, right? So this is how we grew from scratch, from a very minimalistic place. And this now is a very well oiled machine. We have a set of standards that we all app teams follow, right? We have coding standards, we have deployment standards, uh, how to manage deployment, etc. It's very difficult to because of this iframing, it's very difficult to manage deployment. Now we are not deploying only one single repository, right? Previously, that was the case uh, in this scenario, right? Where we were only deploying this main repository, but that's not the case anymore. So now we are deploying different apps, and now since the apps have grown, it's very difficult to manage that. So we have come up with standards, different standards that we all follow, and it has really helped us to manage our releases. So, yes, very proud of this work. Obviously, I'm just a small part of a very big team. I have not done all the things that I've shared here. I'm just a representative of the entire team. But it's very good to see how the app has grown from zero till here. And we have really evolved over time. And it's also good to see that we have evolved in a way that was suitable for us and which worked for us. Do you have any thoughts on the workflow that I shared? Do you have other alternatives that we could try out? Please let me know in comments. And as usual, thank you for watching and see you soon in the next video.